Hey, AP PreCal, it is Miss Kosh. This is Mr. Passwater's Tube 2 notes, which connect sequences to functions, basically, is kind of my shorthand version of this. I created my own notes and already taught them, and now I'm working off of his and haven't looked at them. So here we go. It says in the last section we learned that arithmetic sequences, it looks like arithmetic, but it's arithmetic, sequences behave like linear functions, and geometric sequences behave like exponential functions. We will look more closely at these connections today. Fantastic. Hang on, I'm going to put this to the side. So the formulas, it makes a little more sense why AP PreCal likes these formulas, whereas I like a sub n equals a sub 1 plus n minus 1 times d, because this one relates directly to the slope-intercept form, where here's your initial amount, which is b, and here's your d is your common difference, which relates to your slope, and then your variable n relates to your input value n. That's a better way to say it. Your input value here relates to your input value there. Okay, and then this one, a sub n equals a sub k plus d times n minus k. This is the point slope form. You're used to seeing the point slope form, y minus y1 equals m times x minus x1, but they're calling this I think that's a subscript of I. I'm gonna let you zoom in and tell me. Do you agree? Is that an I? I don't quite know why it's I. I guess it's the initial amount, but it's not the initial amount, so I don't know why they use an I, but that's what they do. But if I come back over here and add y to the other side, it gives me this equation. And it corresponds to, you have a particular output value, here are the output values, times your common difference or your slope, with plus your common difference or your slope times your input value minus the what do I want to say about that? The term number, like the input value for this output value. Okay, that didn't go well, but there you go. And then likewise, the geometric corresponds to the exponential, and this I think we're used to seeing a times b to the x or a times r to the x. This one, we don't see this one as often, but there you go, or at least I haven't. All right, it is important to recognize and understand the similarities and differences between linear and exponential functions. A linear function would follow this form, whereas an exponential function has the variable and the exponent. Over equal length input values intervals, the output value change at a constant rate. So when it's linear, it has a constant rate. Over equal length input value intervals, the output values change proportionately. So you can multiply the output values by something to get the next one, is kind of how you think about that. The change m in y is based on addition. The change b in y is based on multiplication. If you have 2 points, you can write the equation of a linear function, exponential function, arithmetic sequence, or a geometric sequence. Okay, so if I give you, so basically like, if you have, I don't know, my birthday is 6/17, and my nephew's birthday, who's taking this class, is, no, it's not 10, it's 11/14. Sorry, Michael. Okay, and so I could find the equation of the line. I could say that or I could say this is a sub 6 is equal to 17, and a sub 11 is equal to 14, and I could come up with that equation. That's what they're telling us there. Okay, let's see more of his notes. This is probably good that I'm doing it because I didn't put tables in mine. But you know AP PreCal loves their tables. Selected values of several functions are given in the table below. For each table, determine if the function could be linear, exponential, or neither. Okay, so what do I see here? I see 0, 3, 6, 9, 12. So those have a constant interval. What am I doing here? I'm subtracting 2. And so this is linear. Where the slope, well, the slope would be -2/3, but there we go. On this one, we are, oh, I see perfect squares. As soon as I see perfect squares, I know that it's not linear or exponential, so neither. Well, and we added 1, we added 3, we added 5, we added 7. I multiplied by, well, you can't multiply 0 by anything to get to 1. I multiplied by 4, I multiplied by 9/4. Okay, no, that's annoying. On this one, once again, we have a constant difference here among our x values. And then I multiply by 2, by 2, by 2, by 2. And so this is exponential, where your r value is equal to 2. Well, it's not exactly 2 because of these. So we just won't say that. On this one, I'm adding the same thing the whole way down, and I'm multiplying by 1/2 as I go here. So yes, this is exponential also. Okay. Oh, wild rumor is spreading that Mr. Passwater won 3rd place in the world's strongest man contest. Good job. Mr. Passwater probably didn't start the rumor. I like to do that too. I like to put myself in people I know in word problems. The number of people that have heard the rumor can be modeled using a geometric sequence where the 43 people had heard the rumor on day 3. So we could say G sub 3 is equal to 43. And 140 people had heard the rumor on 140 people on day 6. According to the model, how many people to the nearest whole number have heard the... Okay, so what we're looking for is G sub 10. So G sub 6 would be equal to G sub 3 times R cubed. So we're plugging in what we know, 140, 43. This one I would definitely use a calculator. 140 divided by 43. Well, that didn't reduce. Okay, let's take the... let's raise that to the 1/3 power. Okay, so our R value is approximately 1.4821. You know what? I can store that value. If I come here, I can store this as, let's call it R. Where is R? There it is. And so my R value, I have stored it. I don't have to worry about hanging on to decimal places or rounding until the very end. So what I did on there's a way, the TI people look for STO. You're going to stow your value. That was an attempt at being funny. My Casio people right here is this little arrow. And so I hit, it had to say like the previous thing store as, and then I went alpha R. Okay, so now what am I trying to do? I'm trying to find, well, I know that G sub 10 would be equal to G sub 6 times R to the 4th power. So I can take G sub 6, which was 140, and I can multiply it by my R value, which I stored, raised it to the 4th power. So I'm going to say 140 times alpha R, nope, not Q, alpha R, there we go, raised to the 4th power. And to the nearest whole number, how many? This will probably show up in multiple choice. They probably would not give you a 675 and 676. I would say we haven't made it to the 76th person, the 676. I would say 675 people. That's a good rumor. Very nice. Okay, but if I rounded wrong, whatever. Okay. Okay, a large theater has a row of seats where the number of seats in each row can be modeled by an arithmetic sequence. If the 5th row, so A sub 5, has 31, and the 11th row has 49, determine how many seats there are in the 25th row. A sub 25 is what we're looking for. Oh, you can't see what I'm writing. Okay, so I know A sub 11 is going to be equal to A sub 5 plus 11 minus 5 times my common difference. 49 is equal to 31 plus 6D. So subtract that, what do I get? 18 is equal to 6D. So each row has 3 more seats than the row before it. And so I can say A sub 25. I didn't actually have to find the nth term, so I'm being lazy, I mean efficient. Plus, okay, so this is what? 14D. So if I'm at the 11th row and I want to get to the 25th row, I have to do the common difference 14 times. And so this is 49 plus 14 times 3. I don't feel like doing arithmetic. 49 plus 14 times 3. I mean, I can, but anyway. There are 91 seats. I feel sorry for the poor little darling who has seats, plural, who has to sit in the middle of that row. Can you imagine climbing over 45 people to get to, oh, that's no fun. Anyway, I hope you get a chuckle out of that. Like, subscribe, comment, and as always, go practice.